Welcome back to Data-Driven Engineering. In this module, we're going to be talking about text data analysis and specifically how to import and analyze text data that might come in as a comma separated value file or a tab delimited or some other type of text data that we can import, analyze, and then visualize the results. We're going to do that with automotive data today. So if we look at this link right here, automotive data, it just shows how to collect data from a car. You plug in one of these modules. Some of them are very inexpensive. Some of them are a little bit more expensive. We're going to work with some data from the OBD Link MX today. So it's provided for you here. You can follow along here from the Jupyter notebook that's here on GitHub if you'd like to use this one. Or you can select this, the Google Colab link, and it'll bring it up in your web browser, and you can just run from the web browser. Okay, so I'm just going to come back. All right, so I'm going to get this one right here, and then we're going to work through this assignment together. And I have two vehicles. I have this Ford Explorer that was driven in Puerto Rico, and then another one, this Chrysler minivan, Pacifica, that was driven in Iowa. And we're just going to compare the performance of the two and just how they do with fuel economy and some of the other metrics for the vehicle. So let's go ahead and just start by importing. We're going to import some packages that we're going to need to read this data. We're going to get NumPy, we're going to get pandas, and we'll get matplotlib. Now, let's go ahead and import our comma-separated value file. It's stored as a zip file, and we can read that directly into pandas or into Python with the pd.readcsv. And we'll just read it in, and there's going to be some rows that we're going to skip here. Let's just go take a look at this file. We'll just download it ourselves and take a look. Okay, so I'm going to open up this file. You can see it's a CSV file, and I'll just open it up with Excel just to show it just before we import it with pandas. You'll notice it's stored as a zipped archive. Now pandas has no problem with that. You can give it a URL, and this is just the raw file that's returned from that device. So I have a couple leading rows that show the start time, and then another one, fuel calculation method. We don't need those, so we want to skip these two rows as we go on. And then you can see all of the other values here. Okay, I'm not going to save that, but then I want to open this with a text editor. Okay, so let me just go ahead and paste that right here. And then I'm just going to open with, I'll show more options here, and I'll do Notepad++. So I'm going to just open it with a text editor, show you what it looks like in kind of the raw format. You've got these first two rows. You could just delete those here if you wanted to. But then the other ones are just separated by commas. You'll notice here there's a space. That's going to cause a problem. Not a problem, but we want to eliminate that space later. And then all of our numerical values here. So each one in a separate row, all of the values are separated by commas here. All right, so that's the data that we're going to be importing and working with in our Jupyter notebook. So let's just come back here. We've got our data file. Okay, I need to run this one first. Okay, so then I'm going to run this, and then let's go ahead and summarize the data. Okay, I'm just going to describe it. It shows me the count, mean, standard deviation, min, and then the quartile information here for each of these. And you can scroll over and see all of the different things that it collected from that vehicle. All right, now let's go ahead and display just the first 10 rows instead of just summarizing it. I'm going to use head, and if we put 10 in there, it's going to do 10 rows. And if you do something like sample, it'll just take 10 random rows. All right, so here are our values right here. You can also do end if you want to. Let's see. It's data.tail instead. All right, so there's the last 10 rows. All right, so let's go through some data cleansing for this. Now, one of the things that you might have noticed when we did the head is that, There's a little bit of some bad data here, like the bearing degrees, -1. So something hadn't quite initialized there. We also see some barometric pressures. Those are 0 before it becomes good again. So we need to filter out some of this bad data that we see. So let's go ahead and trim the column names. That's the other thing we need to do. These column names have a space preceding them. So I'm going to get the columns, and there's what they are before. So you can see this space right here and the space right there. So I want to remove that. Let's go ahead and just strip that out. For each one in here, we're going to strip it. Okay, we're going to strip each one, and then we're going to assign it back to data.columns. So let's go ahead and just look at this before and after. So here we've eliminated that space that was right there. All right, it's going to be easier to reference the columns that way. Let's also remove the rows with bearing degrees -1. So we'll say, we only want the data where the bearing degrees is greater than or equal to 0. And then it's going to eliminate all of the other rows that have bearing -1. Okay, so I just set up a condition here. Now I could put in an and then do another condition. Don't forget to put parentheses around this like that. And then you could have another condition if you want to add additional conditions to check. Okay, let me go ahead and run that. And then let's just look at data.head. All right, so we've eliminated just those first 18 rows. But let's go ahead and also eliminate the last 5 rows. There's, let's say we just wanted to eliminate those as well. Okay, so I've done ILOC, iLocation. Okay, and then I did the colon. Start basically at 0 is a shortened way to do that. I can leave that out and go to -5. It's the 5th to last row. So I'm going to keep everything that's from 0 to the 5th to last row. So let's go to data reduction now. We can also take every 10th row. So instead of going 0 to the end here, I can just leave these out and just put my increment in there, my 10th. Okay, if you wanted to reverse it, reverse all the data, and taking every 10th row, you do the negative there. All right, so I'll run that, just reduce the data down. If I run it again, I'll reduce it down to every 100th row because it'll take a 10th of the 10th. But let's go with time, set time as the index now. Okay, so we have insert cell below. Let me just show data.head. Okay, we have the index now. That's this original index. You can see every 10th row, but I want to make time the index. So to do that, I just use the set index, and I say that I want this one to be my new index. And I'll put in place equals true to make it so I don't have to do data equals like that. Okay, so that'd be equivalent to doing this, but just to shorten it, I can say in place equals true. So it just operates on data just like that. All right, so let's go ahead and look at this now. I'll just run this one again. Okay, and you can see that time is now my index. It's how I refer to each row. That's going to be important later for plotting and things like that. Let's go ahead and add a column. Okay, I want to add average fuel economy. This is miles per gallon. It's not in that list, so I'm going to take my trip distance in miles divided by my trip fuel in gallons. And that will give me my average fuel economy as I go. Okay, let's go ahead and run this one, and then let's visualize some select data. I'm going to select some columns, just the columns that I want to see in this list, and let's go ahead and just plot this with a tight layout. I'll save it as a PNG file, and then we'll show it. All right, so here it is. I've got some of the data like vehicle speed. Okay, I drove for about 5,000 seconds or so. Over so a fairly long trip here. You can see the miles per hour. All right, that got up to 60, 70 miles per hour. You can see the fuel rate. Okay, very low idling right there. absolute throttle position, so you can see how I was driving, my acceleration, also the deceleration. You can see the negative as I was braking, and then the altitude. So you can see here, and then we started climbing right at the last, so about 700 feet. All right, and there's my average fuel economy. So I went up, I was idling for a while, I wasn't moving very much, but I was still using gas, so the average fuel economy came down, and then I was in stop and go traffic, and then it started to climb again as I hit open freeway. All right, let's look at data correlation. So I'm going to look at the seaborne plot. I'm going to do a pair plot on just those data columns. So I want to import seaborne, pair plot, and then just show that. So let's look at the data just for these values here. Okay, this one takes a little bit to generate, but it's a very informative plot. I'm going to zoom out a little bit here. You can see on the diagonal, okay, that's the essentially the distribution of the values. So average fuel economy, you can see the number of samples, and you can see I had most of my samples up here, 30 to 35 for the average. Okay, and you can see others like vehicle speed. Okay, you can see during my travel I had most of my time up here, but significant time idling here or stopped. Okay, fuel rate, and there you can see absolute throttle position. All right, and then you can see this one, acceleration, and then altitude. Okay, so I was mostly lower elevation. At the very end I rose a little bit, and then miles per gallon. All right, so let's go ahead and display our GPS route now. If you need to, you can pip install Plotly. We're going to use Plotly Express here. It's already installed here on my computer. So I'm going to use Plotly Express as PX. And then I'm going to generate PX using a scatter map box. And I'll use my data. Let me zoom in a little bit here. My data, and I want to visualize latitude and longitude. Normally that's all you'd need, but let's go ahead and also add the color of the dots are going to be vehicle speed, and the size are going to be the fuel rate. And then let's use the ice fire max. Size max is 5 and zoom is 7. And then update our layout. So just a little bit with our open street map, and then I'll show it. All right, so let's go ahead and visualize our route that we took. Okay, so here's the starting point, and as you see, I'm going along, and I can, I'm driving down by San Juan, hit the traffic in this area, vehicle speed, I think it was slowed down. I'm trying to remember where it slowed down. I think it was right in here that it slowed down quite a bit as we were getting close to the airport, and then we hit, the freeway, the highway, very low traffic there. All right, but you can see the vehicle speed here on the right. So the darker colors means faster, and then we climbed right there at the end. You can see the fuel economy went down. So, the fuel rate went way up. You can see larger dots there as I'm climbing. Also, when I'm accelerating, going faster, you can see, the larger dots. All right, let's go ahead and export this text file as well. I'm just going to do data to CSV, export data. So I've cleansed it. Maybe I want to use it somewhere else. And there it is as a CSV file. Let me just open this up. And we can see, for example, the average fuel economy that we calculated and some of the other modifications that we made to the file to clean it up and to remove some of the bad data that was there. So there you can see it. At the very end, there's our average fuel economy that we calculated. All right, I'm not going to save that. So now our next activity is we have some more automotive data. Now you're welcome to get one of these modules yourself and compare it, but if you want to just use this, here's another one. This was driven in Iowa for about the same amount of time, and we're going to read it in and then do a lot of the same things that we had done before, but with this new data set. So instead of data, it's going to be DCH. So let's go ahead and cleanse and prepare the data. So just like we did before, I'm going to go a little faster through this. We're just doing it with a different data frame, but it's essentially the same thing. We're going to list the columns. There's our before. Okay, strip it, strip those spaces. And then also where the distance is 0. I was idling a little bit right at the beginning, so I just wanted to remove those. I also want to shift the start time to 0 because I moved a lot of those initial points off. So I'm just going to take my very first time and subtract all the other times, that from all the other times. So I'm going to take I location 0, and then it's going to start now at 0 and then count up after I eliminated these first rows where the trip distance was 0. Now we'll filter based on this bearing degrees. Again, just to initialize some of the sensors, we'll take every 10th row just to reduce it down a little bit, easier to work with, and then set our index. All right, so here's our data cleansing and preparation. In the future, you could set up a pipeline where if you imported a file, it could run through this automatically and then export the data. Let's go ahead and calculate the average fuel economy. We got the trip distance miles divided by the trip fuel. And let's go ahead and create a little bit more sophisticated plot here on time 1 and time 2, just to be able to compare the two vehicles. Okay, we have our Ford and our Chrysler. And so we have speed in miles per hour. Let's do a second subplot, which is trip distance. Third subplot is trip fuel. And fourth subplot will be average fuel economy. So let's go ahead and run this and then just compare the two. So here are the two trips. The Ford and Chrysler are kind of similar in terms of the speed of the trip. All right, and you can see the distance driven was about the same, a little bit further for the Ford. Okay, here's the trip fuel that was used. Okay, the Ford used a lot more there on the highway, and then when we were climbing right there at the end. And here's the average fuel economy for the two vehicles. So the Chrysler, we had much higher throughout, okay, and then it ended right around 40 miles per gallon. And then the Ford had a little bit lower and then ended here about 33.5 versus 39.7. So fairly similar, a little bit more efficient for the minivan. All right, let's create a pair plot now. So I'm going to just use these values for the ones I want to compare. And I'll add a vehicle specification. So data frame is going to be equal to Ford for vehicle. And then DCH, that's the data for the Chrysler. That's going to be labeled Chrysler. Okay, and then I want to combine these two. I'm going to do like we showed in the, if you missed out on this or you don't remember the pandas, come here and then come down to pandas and review how to append data frames. All right, so if you forgot how to do that, come back to that lesson. Here's C1. I'm going to copy it. I just want to create a copy of these two because it's kind of a reduced set based on just the columns that I want. And then I'm going to create a combined one, say C1 dot append. I'm going to append C2 to that. All right, and then I'll reset the index. So I'm going to throw out the index. I don't need the index that's there at the time. I'm going to reset it, and I'll drop it. So it doesn't put it in as a column either. All right, let's go ahead and create a pair plot just with these combined, and the hue is going to be the vehicle, and then I'll show it. All right, it looks like I've got a that's deprecated or be removed, and we'll use concat in the future. All right, so it shows these distributions here for vehicle speed. And you could use this to compare two drivers, for example. In this case, I was the same driver. I was only driving the Ford. Somebody else was driving the Chrysler. I was in the car, though. So we could compare two drivers and see how, I was doing the Ford, so the absolute throttle position, you could see I go a little heavier on the throttle than this other driver right here. Okay, so when I accelerate, maybe I'm a little more aggressive of a driver. Okay, you can also see the acceleration. I have a little bit larger tail here out at the end, a little more aggressive, but this driver tends to accelerate and decelerate kind of in this range. Here's the average fuel economy, and you can see throughout the trip that changed a little bit and it gave a distribution. But the other thing that happens here is we can start to compare some of the variables together. So fuel rate versus absolute throttle position, those are fairly somewhat linear correlations. I increase one, it increases the other. But we can also see some of the others, the dependencies. Particularly we're interested in the average fuel economy and what influences that. So you can see some of these factors here. If I'd put elevation on there or incline or something like that, we might see increased or decreased fuel economy versus that. And you might also want like an instantaneous fuel economy here instead of an average fuel economy to better see the correlation between the variables. Okay, let's look at this other vehicle route. So instead of data right here, we want DCH instead. All right, and then if we plot that, here's the route. Okay, in Iowa, starting at the airport, coming up and around here, and then back over to here to Pella, Iowa. All right, so there's the route for the other vehicle, about the same distance total, and you can compare the two vehicles. All right, so that's it for importing and analyzing text data. Hope you've enjoyed this one. It's fairly easy to do with Python. Just remember this first one, okay? This first one right here, which is just read CSV, and you can read from a URL, you can read from a local text file, CSV file. There's many different types of forms that you can read from. And then once you have it into a data frame form, you can do data cleansing, visualization, and export it.